Myself K. Niranjana from second year CCB. Today I am going to present a topic about inter-process communication. First, we discuss about the introductions of inter-process communication. Inter-process communication is a mechanism that allows a different process to exchange the data and coordinate the execution in an operating system. Why is IPS needed? Modern computers run multiple processes at the same time. These processes need to communicate with each other for efficient multitasking. Example of inter-process communication. A web browser communicates with the download manager to fetch the files without interfering with the user experience. And the purpose of the inter-process communication is enables the communication between processes for efficient multitasking. And next we discuss about IPC necessaries. Multitasking, process coordinations and example. In multitasking, it ensures the multiple processes work together efficiently. In process coordination, it prevents the conflicts and ensures the synchronizations. And examples, web browser and background download managers share network resource. A word process interact with the spelling checker in real time. And next, the type of inter-process communication. Message passing and shared memory. In message passing, it processes the communicate by sending and receiving message. It is the operation of the message passing. Example, email servers and chat application. And next, shared memory. It processes the share common memory space for communication. For example, database servers, multiprocessing system. These two types are the inter-process communication implemented in different ways. First, we discuss about what is message passing. Inter-process communication mechanism where process the exchange data using messages instead of shared memory. And how it works. Process A sends a message and process B receives it. For example, a client sends a request to a server which processes it and sends a response. It is the example of message passing. Its advantages: simple for implement, no need for shared memory management. Disadvantages: slower than shared memory due to message overload. And next, shared memory. A memory segment accessible by the multiple processes. And how it works. One process writes data to shared memory and another process reads it. For example, producer-consumer problem where a producer writes the data and the consumer reads it. For example, faster than message passing and it reduces the message overheads. Disadvantages: synchronization issues like race conditions and deadlocks. And next, direct communication. Process explicitly name each other for communication. It is the definitions of the direct communication. For example, sender P1, P messages. The process P1 send the messages. Receiver P1, messages. Process P1 receive the messages. It is the example of direct communication. For example, simple and efficient for direct communication. Disadvantages: tightly coupled and making it less flexible. And next, indirect communication. Process communicate through mailbox or message coax instead of directly. For example, process A and B send message to a shared mailbox. Any process can retrieve the message from the mailbox. For example, loosely coupled, allowing more flexibility. Disadvantages: increased overhead due to OS message management. It is the disadvantages of indirect communication. And next, buffering. Zero capacity, bound capacity, unbound capacity. First, zero capacity. No buffering. Sender waits until the receiver processes the message. And next, bounded capacity. Limited the queue size. Sender waits, it fills. Unbounded capacity, no limit. OS managed dynamically. It is the buffering of the inter-process communication. And next, inter-process communication synchronizations. In synchronization, why is synchronization important? It ensures the process execute in a coordinate manner. Problem without synchronization, race condition and deadlock. In race conditions, two processes access shared data simultaneously, causing inconsistency. In deadlock, two processes wait for each other indefinitely. It is the two problem without synchronization will happen in inter-process communication. And next is synchronization mechanism. First one, blocking and unblocking. Blocking is synchronized. The sender waits until the receiver processes the message. For example, request response model in web applications. In non-blocking, it is asynchronous. The sender sends a message and continues execution without waiting. For example, notifications in mobile app. And next is semaphores. For definitions, a signaling mechanism that controls the process access to shared resources and how it works. Wait and next signal. For wait, it decreases the semaphore value. For signal, it increases the semaphore value. For example, used in mutual exclusions to prevent the race conditions. And next, mutex. The definition of mutex is a lock mechanism that ensures only one process accesses a resource at a time. For example, it prevents two users from editing the same file simultaneously. It is the definition mechanism for mutex in interprocess communication. Next, we discuss about pipes. A unidirectional communication channel between the parent and child process is called pipes. For example, in Linux, a parent process sends a data to a child process using pipe. For advantages, simple and effective for parent-child communication. Disadvantages cannot be used for bidirectional communications. Next, discuss about named pipes. A pipe with a name allowing the unrelated process to communicate. For example, a logging process writes the data to named pipe, which another process reads asynchronously. It is the definition example of named pipe in interprocess communications. And next, we discuss about message queues and sockets. Message queues. A queue maintained by the OS for storing messages. For example, message get, message send, message CV. First, message get. It creates a queue. And next, message send. It sends a message. And message receiver. It receives a message. There are 3 examples for message queues. Advantages can store message even if the receiver is not ready. Next, sockets. It allows the process on different machines to communicate over a network. For example, client-server communication using TCP and IP sockets. Web browsers connecting to the web servers. For example, supports the remote communication. For disadvantages, higher latency due to network overhead. And we discuss about security and challenges in IPS. First, challenges. Unauthorized access. Process may access shared memory without permissions. And next, message interceptions. Network-based interprocess communication messages can be intercepted. Solutions: implement authentication mechanisms and using encryptions for message security. And next, to discuss about the disadvantages of the interprocess communication. It allows process to share data and resource efficiently, facilitates the parallel executions and improving system performance. Supports communication across different devices. Example, network sockets. It enhances modularity by allowing independent process design. And disadvantages of interprocess communication. Synchronization issues can lead to race conditions and deadlocks. Higher complexity in managing shared memory access. With security risk if unauthorized process access IPC resources. Message passing IPC can have latency issues due to overhead. Conclusion for the interprocess communication. It enables the process coordinations. It supports multitasking and resource sharing and essential in modern OS and distributed communication. Thank you.